So with the trend tending to go toward the SDR radios, are the filters all digital processing, or do they actually still use? the
Yes.
hardware?
Yes.
So when I open up the radio, I'm looking at all those coils and
Take a peek.
capacitors are part of the tuner, right?
No, not necessarily, but you normally would have low pass and band pass filters ahead of the DSP processing.
Ooh, what is that thing? I couldn't stand it.
This is band pass filter board, partially completed.
Oh, is this your kit?
No, it's not a kit.
This isn't what you were talking about?
Yeah.
Oh,
Not a kit.
well, you buy a board and then you buy all the parts and you put it together.
Well, okay, a kit implies that you get all that stuff, all the parts and
Oh.
everything and instructions.
Like a heat kit, the old heat kit type one, yeah.
So what in the world?
There's the processor.
Yeah.
This is the RF board. Transmit receiver. This is the band pass filter.
Avionics and instrumentation.
Oh, really? You got a relay on that board somewhere?
No. Solid state switches.
Transmit receive switch?
No, for the band
I
pass.
don't think they
No,
put
no.
rights to them in
Haven't done that yet, that would be on the low pass filter board. That's the PR switch. Lots of little relays.
And they're physical relays.
Yes,
So how can you have?
physical relays work better than 10 diodes and they're cheaper.
Hey, Bob, we can't see or really follow.
People don't
What
like
kind of doors, electrical doors or?
clicking.
Really? Wow, the way that.
We can't really see or follow, Bob.
That massive amount of current.
Excuse me, what'd you say?
We can't see or follow what that discussion's all about.
No, yes, because I already started the share, so we'll
We'll
do it after this one.
Just start all at once.
All right.
Are we recording?
It says
Yes.
start.
Yeah. Okay, so rectifiers and power supplies. I had to throw in rectifiers because that's part of the general stuff for this sub element. So we basically have two types, half wave and full wave. I'm sure Ed is all up on his rectifiers,
Oh, he knows all of this.
all that stuff. Selenium,
Oh, yeah, I remember
yeah.
I hadn't seen them for a long time.
I don't think they make them anymore.
Aren't they poisonous?
Yeah.
Very.
I wouldn't eat it, no.
I don't eat very much.
But your laser printer drums got the same stuff.
I don't remember this.
Oh, okay.
I'm good.
So in your typical half-wave rectifier, you've just got a single diode, which we call a rectifier in this case. It's still a diode. Usually they're made to handle more power, is the basic difference. And it's conducting on one half of the cycle. Either the positive half or the negative half, depending on how you arrange it. And you, huh?
The two diode.
OZ2s.
Oh, that's a voltage right
Yeah.
there.
OZ.
Oh.
It was a gas.
Yeah.
Tube.
Pink purple.
Yeah, pretty. When I was in high school, I used to repair radios for a used car guy. Of course, they were old radios then, and that was the big thing. Usually you replace the OZ2 or the vibrator.
I remember that.
Or if it was a Ford with a transistor radio, they mount the circuit board upside down in the radio, and it's on the dashboard right under the ashtray.
Oh.
and all the ashes fall down on top of the circuit board and eat it. So I usually have to go and redo traces on the circuit board to fix it, and that's all it was.
They start slacking like GE.
Okay. So essentially, we're going to generate DC pulses out of this, and then we filter it to get DC. And the pulses are going to be at what frequency?
Whatever you put in.
Okay. What portion of the AC cycles converted to DC by a half-wave rectifier?
Baker.
If we have a full wave with two rectifiers, we get a full 360-degree waveform. We get pulses at twice the input frequency. Now it's 120 hertz instead of 60. But it also requires a center tap transformer that's twice the voltage. So if we were doing this to make a 12-volt power supply, we'd have to have a 24-volt center tap secondary in order to do it. Did what?
Oh, Parabay charges for that. They use one.
You can do the same thing with a full wave bridge, which requires 4 diodes, but they come in a package. You just buy a little bridge. And now you only need a 12-volt non-center tap transformer. So you save a little transformer. And the diode bridge probably is no more expensive than 2 separate diodes. And you still get 120 hertz ripple. So what portion of the AC cycles converted to DC by a full wave rectifier?
360. All of it.
What's characteristic of a half wave rectifier in a power supply? What is characteristic? For a half wave,
Only needs one diode.
one diode. Which type of rectifier uses 2 diodes and a center tapped transformer? What's the output waveform of an unfiltered full wave rectifier connected to a resistive load?
Series DC at twice the frequency of the input.
Alpha? Linear power supplies. So we basically take our, for full wave rectifier, usually it'd be a full wave bridge, and add a voltage regulator circuit to it. In this case, it's a linear. And we've added a pass transistor to handle the current because the 7812 is only good for what, 1.5 amps or something like that, I think. So if this had to carry, in this case, they're showing 5 amps out. That's why you have that pass transistor.
Cool.
Huh?
Well.
5 amps. Yeah.
Because
Because the 7812 won't do 5 amps. Unless you put it on a really big heat sink with a fan, maybe. I don't even think then you can do it. Normally, they're limited to around 1 amp or 2. In fact, there's one in there. It's running at about 1 amp, and it gets quite hot without the fan. Huh?
You don't want that.
I know. I'm contemplating replacing it with a little switcher module. They make as a drop-in replacement. But it may add more noise. Okay, let's see. So we got an analog voltage regulator, a bleeder resistor, so that you dissipate the charge on that output filtering capacitor, even though at 12 volts, it's not that big a deal. You definitely need it when you're talking about a high voltage supply. Which of the following components are used in a power supply filter network? In the filter part.
Oh, I'm sorry.
Even though they didn't show an inductor, a lot of times there'll be a choke.
Yeah, I didn't say actually.
What's the function of a power supply bleeder resistor? We call them linear power supplies because they normally use a linear voltage regulator, or and it's usually an IC like that 7812. And they just regulate by varying the conduction of current through this control element. And in this case, we added an additional transistor to handle more current. But there's a similar one inside that package. It's just not rated for really high currents. So circuit E72 is a voltage regulator, and the control element is Q1. This is very simple with a Zener diode as your reference voltage. And you've got C2, which is basically filter out any kind of ripple, because you're feeding it from that 25 volts, which might not be a pure DC, so that you have a fairly stable reference voltage on that Zener. And what else? Let's see. Well, and the Zener is D1. That is your voltage reference. Q1 is the pass transistor. So, simple circuit. So what type of circuit is shown in E72?
Linear voltage regulator.
Charlie? How does a linear electronic voltage regulator work?
Delta.
Delta. You vary the conduction of that pass transistor. What's the purpose of Q1 in the circuit shown? Charlie? What's the purpose? Oh, what's the purpose of C2 in the circuit shown?
Yep.
Okay. Designers typically use Zener diodes as voltage reference. You can buy voltage reference diodes, which are just more precision and cost a lot more, but I think it's still essentially a Zener diode, might have some temperature compensation. So D1 in this case is a Zener, we already talked about. So what device is used as a stable voltage reference?
Hey.
An SCR, right? There are two kinds, yes.
It seems to me like I recall back in when I was doing there were schematics and now they reference Zener values and schematics of Z1, Z2, but they're the
I've seen it both ways.
Okay.
I mean, it's a diode,
Yeah.
and how would you represent a varactor? As a D or a C? Normally it's a D.
Yeah. Okay.
And the Schottky is normally a D, not an S.
We go by the symbol.
But that did bring up a question on the previous one. I've debated, is it better to have more information and then a whole bunch of questions about it, or spread it out like here's a description and here's a question, like the last one, like Zener diode? as far as understanding it? Does it make a difference? Because in one case, you have to remember it longer. But if you do it quickly, does it reinforce it? I don't know. Which of the following describes I was going to talk about it, but all right. Three-terminal series regulator. You buy a single package like a 78 12, 7805. And they're normally a series regulator package. You can also have a shunt regulator where instead of being a pass transistor, it shunts current. So it's inefficient because if you have no load, it's still passing the same amount of power through that shunt. You don't see those very often.
That's cool. Purple wood would be the application for that.
I'm not sure. Maybe in a case where you pretty much have a constant load all the time, as opposed to a varying, I don't know. I don't think it would make a very good bench supply. Which of the following describes a three-terminal voltage regulator?
Series regulator.
You didn't read it. Which of the following types of linear voltage regulator operates by loading the unregulated voltage source?
David,
Series. Of course.
Yeah. Dropout voltage. It's the minimum input to output voltage required to maintain regulation. So if that voltage regulator package, say, has a dropout voltage of 1.5, and you're trying to do a 12-volt supply, it says that you would need a minimum of 13.5 volts into the regulator for it to regulate 12 volts. And the example here is with a 9-volt one and a dropout voltage of 2, so you'd have to have 11 in. Ooh, there might be a math question coming up.
I didn't bring it up.
What's the dropout voltage of an analog voltage regulator? Charlie. Let's see. The power dissipation on a series linear regulator is the voltage drop from input to output multiplied by whatever the current is. So that's the power. So it may require a large heat sink depending on what, if you're doing a couple 100-watt linear power supply, you probably got a big hefty heat sink in it. Like some of those benchtop Lambda supplies that you can't hardly pick up.
Bob,
That's how long they last.
Bob, a footnote about the shunt supplies. My memory is a little bit weak, but I believe solar and wind generators are typical examples where a shunt regulator is preferred.
Why?
Well, because the solar is basically a current source and the open circuit voltage can get too high. And similarly with a generator, with a windmill, they're typically inductive, and at high wind speed, the voltage gets pretty high too. So
Yeah.
it's kind of a protection thing to keep the load there.
Okay.
And in the case of the windmill, it also keeps the thing from spinning up too fast too.
Okay. So, well, that would make sense then, because if nobody's got their lights on, the windmill could get going pretty fast, huh?
Exactly. Well, and generate fairly high voltage. And the solar cell being a current generator, the open circuit voltage can get pretty high. So it's best to keep them loaded.
I still think windmills are only good for grinding grain and flour. Which of the following calculates power dissipated by a series linear voltage regulator?
Voltage difference.
All right, switching power supply. Why? Because they're cheaper. They're lighter. You don't get a hernia picking it up. They're more efficient. They typically use a high frequency inverter. They'll rectify your AC voltage and generate 100 and something volt DC, and then run that through an inverter where they can go through a transformer and it's kind of like we talked about the Class D amplifier. You're doing a pulse width modulation through that. So you're starting with essentially 100 volts or so DC, and then you're going to pulse width modulate that depending upon the load and what the error is if you try whatever the voltage you're trying to regulate. So as you draw more current, then it's going to increase the pulse width. And then you're filtering it like you do in the Class D amplifier. So it's the similar kind of control loop. It's a lot more complicated, takes a lot more parts. They're small, but still a lot of parts. They actually don't cost, they cost less because in the big linear, the cost is that power transformer. But they also can generate a lot of RF noise because you're doing a lot of switching and you're generating lots of square waves. Let's see, this is kind of same thing I talked about. You know, they operate up in the 200, 500 kilohertz range. Some of them, I've got a couple where you can actually change the switching frequency. In case it's creating a noise problem, you can vary what the switching frequency is. So if you're picking it up on your radio, you can go twiddle the knob and move it a little bit.
But you're just moving the noise.
Yeah, you didn't eliminate it, you just moved it. You try to get it out of your passband. So how does a switch mode voltage regulator work? Bravo. Did somebody say Charlie? Why is a switching type power supply less expensive and lighter than an equivalent linear power supply? Charlie. Which of the following is characteristic of a switch mode power supply as compared to a linear power supply? Yeah, I don't think A is true. And it requires more components, huh? I don't know about stability. Right. Okay, high voltage supplies, because we typically operate amateur transceivers on 13.8 volts. Um, and if you had a tube type linear, they operate on much higher volts. You might have to have a high voltage supply. And normally you're going to get, if you don't have what they call a soft start or step start circuit, and there's lots of ways they do that. One is varistors, which is what I use in my CNC stuff, where it has a higher resistance at a higher current. And as the current drops, the resistance drops. It's a weird little device, but it's a surge suppressor. So when you first turn it on and you got these giant filter capacitors that look like a short circuit, it blows your fuse unless you do something like that. So you need something to allow the filter capacitors to charge more slowly, have less surge current, or inrush current, as they call it. This is a kind of a typical circuit where, and a lot of them will have a relay. So initially, you're having this series resistor, power resistor, in series with the load and the capacitor. So you're limiting the input current, and then when it senses at a certain point, it bypasses that through the relay. What's the purpose of a step start circuit in a high voltage power supply?
Delta.
Delta. Okay, if you've got multiple filter capacitors in series, which typically you find for a high voltage supply, you'll normally see these equalizing resistors, which also act as bleeder resistors. So they equalize the voltage across them. And it also gives you a minimum load. Sometimes regulator circuits don't work when there's no load at all. That was the case for all the old AT type power supplies in computers. It had to have a load on it. So if you pull one out and want to use it as a bench supply, you have to put a load resistor on there when nothing's connected to it, or it won't operate. Easy way is just do a LED and a resistor to tell you power's on. What's the purpose of connecting equal value resistors across power supply filter capacitors connected in series?
Delta.
Yeah, we finally got a delta today. Okay, sometimes our power supply is a battery. I guess the main thing is when you're using a battery, you need to know how long you're going to be able to operate. So you need to know the average current drawn by whatever your equipment is, and then the amp hour capacity of the battery, assuming it's fully charged. And you just divide the amp hour rating by the average current, and you'll find out how many hours you think you can operate. Although I'm not sure that the 12 amp hour rating in this case is valid down to the cutoff voltage for like a lead acid. You really can't operate it below 11.5. So even though it's got 12 amp hours in it, I'm not sure you get 12 amp hours and stay above that minimum voltage. So how is battery operating time calculated?
Charlie.
There we go. Amp hour.
Look at me like that. Man. Second here.
Okay, now you can also have a solar array connected to your battery. A lot of people I know do that as a backup for emergency operations. So most of the solar arrays put out something like, at least the ones I've seen, like 19 volts typically. So you got to reduce that down to whatever your charging voltage is for the battery. Usually maybe a volt above what its nominal is. And they sell charge controllers just for that purpose, to work between a solar array and a battery, and you have to buy one depending on the battery. It's going to be different if it's a lead acid than if it's a lithium iron phosphate or some other lithium battery. I've seen some where you can select, they're a lot more expensive, but you can select the type of battery. The cheaper ones, you have to buy it specifically for the right type of battery. So what's the purpose of an inverter? Oh, let's go back and see.
This can't produce a new.
Yeah,
Oh.
missing a line.
So what's thermodynamics?
You would use an inverter if you want to generate
Heat transfer.
AC, if you've got something
Do not drink
that
warm
runs on
water.
AC current.
Did you know that memory loss is not a condition of the mind? Most people don't know this, but the real reason behind Alzheimer's and dementia has less to do with age, lifestyle, or genetics than we first thought. Here's the problem. No matter what type of pills you take or what treatments you try, you're only treating the symptoms. Listen up.
Is that me?
Eventually, you'll start to forget names or
Where's
tiny
that coming
details,
from?
lose your keys, your glasses, or forget why you walked into a room. This is when your family starts wondering if you're able to take care of yourself. And next thing you know, you're being sent off to the old folks' home. Now, luckily, there's a way to solve this. A renowned neuroscientist made a surprising discovery while studying a little-known area of the
Well, that
brain.
was mine.
He was surprised to discover that memory issues seem to derive from one leading
I don't know
cause.
where that's coming from.
Most importantly, he revealed a simple
All right.
Chuck?
Now it's muted. Yeah. I think it's still here. Doctor got an open mic.
Well, he does now it's muted. It's not.
Was that you?
Yeah, I'm sorry.
Okay.
Pay attention.
Did I lose?
Looks like you're. putting
Baker,
a
of course.
stove on here from the International Space Station.
Well, I'm trying to figure out where it went.
Flying over your head.
Yes.
It's. Oh, there we go. I guess.
Oh,
But now I'm not full screen.
David, I guess would be the answer for that one, but
I don't know how to make it full screen.
typically you need more than just just an inverter. You need some kind of a regulator thing so that the solar panel output is suitable for some sort of a storage battery. And then you may want an inverter so you can get AC, but I would not put an inverter directly to a solar panel.
Unless this was.
Yeah, I don't think that question's in the right place. It's for different. Well, An inverter, I mean, before we got distracted, so we had questions about place.
Yeah, on what's the purpose of an inverter connected to a solar panel output? Well, the only reason you'd have it was to convert DC to AC.
Yeah, because the slide before, we're talking about regulators. and
I know.
Seems-
It seems like you're missing a slide or it's kind of in the wrong place, but that's the only place we talk about
Yeah.
solar. So, my bad, but I don't know how to make this full screen anymore.
Top there, that probably has.
You can alternate.
Oh, that's actually.
No, that didn't fix it.
Oh, no, it's better, what you mean by that?
Oh, it says my screen sharing is paused now. Okay.
Ah, all those things. Or is that it? So-
There we go. Now, where were we?
Down in solar disarray.
But they just do that in.
Well, the inverter, you know, those questions don't seem to, they still have samples. Something.
Oh, this personally really is.
Yeah.
A basic question,
Okay,
why do they call DC to AC converters inverters, and then an inverter just flips something upside down? Like a lot of inverters.
I don't know. It's just the way it is.
It's not inverting.
What they've always been called.
Call it a converter,
Difficult.
but they always seem to call them, not just in radio, inverters.
Something about the step-up function is implied in there.
Yeah.
Yeah, something that.
Yeah.
Quite correct.
Oddball question.
Well, yeah, it seems like they're not in the wrong place.